All right. So hello, everyone. My name is Judy Larson. I'm from Canada and just one of the trustees and one of the members involved in organizing virtual seminar series. And so we thank you for attending today and coming to our session. We've got a lovely theme for you coming up on differences in adults' interpretations of various visual media sources, the what, how, and why. And we have three excellent speakers here today who will each be introduced individually. And some of these speakers are also in relation with NNN, which will be also introduced very shortly. So we'll begin with Diane doing a quick introduction to ALM and ALM's theme and purpose. And then we'll have Ido introduce a little bit of a little bit more about NNN as well.
Thank you very much, Judy. Well, I'm delighted to be here. It's not the first seminar I've been to, because I've been in ALM since, well, quite a long time now. Let's just say it's quite a long time. It's the first time I've been here as chair of the trustees. So I'm delighted to be in that position and able to introduce the first of this year's seminar series. Will be followed by others. One of the things I really value about ALM is the fact that it is an international forum, and that we find similarities across borders. We can exchange across borders, across continents, and we find things in common that we're pursuing, that we're interested in. So that's, to me, one of the real joys of being a part of this international organisation. But we're really, this is important collaboration for us, that we don't just stand alone, but we have connections and networks with other organisations with similar interests. So all I want to say is thank you very much for coming. Thank you to the seminar planning team and for Judy in particular for heading that up and chairing the session this evening. So I'm just going to pass over, I think, straight to Ido, if that's all right, Judy.
Okay.
All right.
So hello, everybody. Thanks, Diane. Thanks for asking me to do the introductions. So I was asked to say a few words about NNN, having some loose connection with NNN because I'm a member of the editorial board of the journal of NNN, and I know a little bit about the organization. And I'm also a member of ALM. So we have today a seminar that emerged from a collaborative effort between ALM and NNN, the National Numeracy Network in the USA, and we have Sam Tunstall here, who's the president, right? The current president of NNN. And I want, first of all, for the benefit of the people from ALM, to distinguish between NNN and ANN, the Adult Numeracy Network, which is another American organization. And some members of ALM are also members of ANN, and we have Linda here, Linda Ginsberg, who's from both organizations, and Eric Appleton, who's from ANN, and so on. So ANN is an organization that was established at the same year that ALM was established, and in 1994, and it is made up of practitioners, 4 practitioners running workshops and resources and other kinds of things, mostly for practitioners in the United States, and most of them teach in mathematics and numeracy courses or classes in adult education programs in the United States. But today ALM is teaming with ANN, which focuses on the promotion of quantitative literacy and quantitative reasoning and numeracy among college students in the tertiary institutions and universities in the United States. And we are fortunate today to have 3 speakers, 2 affiliated with NNN and 1 affiliated with ANN. And I'll introduce them very shortly, but before that, I just want to say a few more words about NNN, because some people from Europe are not familiar with the situation in the United States. So some or many American colleges also take in students who are non-traditional students, who are older students, who are working people, or who may have a poor background in mathematics or negative attitudes and beliefs regarding mathematics. but almost all American colleges and universities require everybody to take at least one quantitative course as part of their academic studies, regardless of the subject that they study. And because of this, many American colleges offer quantitative courses that are not called mathematics. They are not pure mathematics, but they very often focus on other kinds of things, on a mix of quantitative reasoning, quantitative literacy, and teaching mathematics in a way that is more applied, hoping to improve connection with societal issues, improve motivation, improve functional numeracy at more advanced levels at the college level. So these teaching contexts, although they focus on colleges only, connect very well with the goals of ANN and with ALM, and all of us are in one way or another interested in promoting the ability of adults to function effectively in a quantitative world. So with this little introduction, I hope that I didn't make too many mistakes about NNN and ANN. Thank you, Sam, for the nod. So let me introduce our first speaker, the Basmita Basu. I hope I am not mispronouncing your name. I apologize. So very briefly, the Basmita is a faculty member at the New School, which is a private research university in New York City in the United States. She grew up in India, where she worked as a high school mathematics teacher for a few years, and then she completed her doctoral studies in mathematics education in the United States. And she's now an assistant professor of mathematics and quantitative reasoning and the director of the quantitative reasoning program at the New School. So Basmita, go ahead.
Hello, everyone. Firstly, welcome, to this wonderful first of many sessions, as you mentioned. I'm very excited to be here and very excited to share my work with all of you. I do have recorded my presentation. However, I was listening to the recording myself. It's very fast because of the limitation of 10 minutes. So I can either play it, but I can also present it, but that might go over time. So let me actually play it, right? But if you have any question, please feel free to ask me during the question answer session. Give me a minute. I should be able. Okay, there you are. Let me know if you have, if you can, listen to it. All right. Hello, everyone. My name is Basmita Basu, and I'm an assistant professor of mathematics and quantitative reasoning at the New School. Today, I'll be presenting the findings of my study investigating students' interpretation of graphs published on public platforms. Today, most magazines, newspapers, and television use some forms of visualization to present complex information in simple and accessible way. Research shows that visualization can highlight important information that might otherwise be overlooked or difficult to comprehend. Our brains are better able to process visual information and identify important patterns and trends in numerical data. Although there is a prevalence of visualizations in news media, misleading graphs are equally widespread, making readers vulnerable to false information. For example, the bar graph that you are seeing on your screen was published by Georgia Department of Public Health. The bar graph represents the confirmed number of COVID-19 cases in 5 counties of Georgia. So if you look at the bar graph, it gives us a sense that the total number of COVID-19 cases decreased with time. However, if you look at the x-axis carefully, you will see that the dates are not plotted chronologically, which is giving us an illusion that the total number of COVID-19 cases decreased with time. While creating and presenting misleading graphs can lead to misinformation, not every misleading graph is someone's deliberate attempt to distort data. Readers can also misread well-drawn graphs due to lack of comprehension of symbols or grammars used in the charts. A research done by Pauletti and colleague found that graphs that we find in school textbooks are distinctively different from the graphs found in scientific journals. According to the study, this difference might partially explain why students feel unprepared to interpret real-world graphs. Research also shows that schools often teach graphs through abstract problems, and they often prioritize students' mathematical proficiency rather than focusing on the real-world context in which graphs are designed. Hence, it's important that we reimagine school graphical literacy. According to Durr, if we can provide students with the opportunity to encounter real-world situation where comprehension and interpretation of graphical data is required, that might help them to interpret graphs published in public platforms. As a result, in this study, we focused on two particular research questions. Number one, how proficiently can undergraduate students comprehend graphs published on public platforms, and to what extent can undergraduate students identify misleading graphs published on public platforms. Accordingly, we implemented our study on 19 business administration students enrolled in a private research institution at the northeastern region of the United States. To measure students' interpretation of graphs, we used Kursiv's framework of graphical literacy, which has three components. Number one, students' ability to read the data. That means to what extent students can extract data from the graphs. Students' ability to read between the data. That means to what extent students can identify relationships between variables presented in the graphs. And number three, student reading beyond the data. That means students' ability to make prediction about the future based on the information given in the graph. We gave students a worksheet containing 4 graphs extracted from public platforms. The first graph is a graph on per capita income of Black and white Americans. It was taken from Business Insider. The second graph was a bar graph taken from Fox News. It was on Facebook's US employee breakdown. The third graph was again a bar graph on the total federal welfare received by the people in the US. It was presented in the Senate Budget Committee by the Republican staff. And the fourth graph was on joblessness by quarter. It was published in Fox News. Now, because one of the primary goals of this study was also to see to what extent students can identify misleading graphs published on public platforms, out of these 4 graphs, 2 graphs are misleading one. The graph on federal welfare and the joblessness by quarter, these are 2 misleading graphs. In order to measure students' ability to read the data, read between the data, and read beyond the data, with every graph, we gave 3 questions to the students. To measure students' ability to read the data, we asked students questions such as, what is the per capita income of white Americans in 2018, or approximately how many people lost their jobs in September 2008. For questions like this, students could extract information directly from the graph. To measure students' ability to read between the data, we asked questions such as, a local news agency claimed that the gap between the per capita income of the Black and the white Americans increased from 2002 to 2021. Do you agree with the claim? Now, for questions like this, students would have to focus on the data given in the graph and do some mathematical calculation to find out the possible relationship or connection between the variables given in the graph. To measure students' ability to read beyond the data, we gave students some hypothetical situation which required some mathematical calculations. For example, we asked students questions such as, previously in Facebook, 4,000 out of 10,000 employees identified themselves as Asians. If Facebook hires 1,000 new employees, 100 of whom are Asians, what percentage of the total Facebook workforce are Asians? Now, findings. The findings of the study suggest that for all the 4 graphs, students did not have trouble reading the data. That means they could successfully extract information given in the graph. However, students experienced some difficulty when it came to reading between the data and reading beyond the data. Particularly for the 4th graph, which was on joblessness by quarter, published by Fox News, students had trouble reading between the data and reading beyond the data. For the sake of time, I'll just present the findings of the 4th graph. Now, to measure students' ability to read between the data, we asked a question such as, a local news agency claimed that joblessness increased at a constant rate between December 2007 and June 2010. Do you agree with the claim? And for every question, we also asked the students to justify their responses. Based on the responses students gave, we saw that 9 out of 19 students answered correctly to the question and 10 out of 19 students answered wrong to the question. Now, students who answered wrong, that means they said they agreed with the news agency and they said that joblessness did increase at a constant rate. 8 out of those 10 students focused on the shape of the graphs in order to justify their responses. 1 student focused on the number given in the graph but did not do any mathematical calculation, and 1 student did not give any justification for their response. Now, the students who focused on the shape of the graph, they gave reasonings or they wrote justifications such as, the line is pretty straight, which means that it is a steady and constant. Another student said that due to the linear slope of the graph indicating the constant rate. So students who identified that the joblessness did increase steadily or at a constant rate, or primarily focused on the linearity of the line in order to reach to that conclusion. Now, the 9 students who answered correctly to the graph and disagreed with the claim that joblessness increased at a constant rate. Now, 7 out of those 9 students focused on the number given in the graph and engaged in some form of mathematical calculation. 1 student focused on the shape of the graph and 1 student focused on the number given in the graph, but they did not do any mathematical calculation. Now, the 7 students who focused on the numbers and did some mathematical calculations, they came up with reasonings such as, 1 student said that September 2008 to March 2009, that means the second quarter, the joblessness increased from 9 million to 13.5 million. So that's a 50% increase. Then they focused on the next quarter and said that March 2009 to June 2010, the joblessness increased from 13.5 million to 15 million, and approximately that's an 11% increase. So for every quarter, they focused on the number of job losses that occurred and calculated the rate at which that increased, and found that the rate of increase of joblessness was not constant. Another student said that the graph shows that between December 2007 and September 2008, that's 9 months, job loss increased by 2 million. In the next 6 months, that's between September and March, it increased by 4.5 million. And lastly, in the 15 months after March 2009, it increased by 1.5 million, meaning it slowed down. Now, to measure students' ability to read beyond the data, what we did is that we compared students' responses in the previous question and this question. So in the previous question, as you remember, 10 students answered incorrectly to the previous question, and those 10 students also answered incorrectly to this question. Now, our interest laid in these 9 students who answered correctly in the previous question and identified that job loss did not happen at a constant rate. So we wanted to see these 9 students who identified that job loss did not happen at a constant rate. How are they predicting what would be the job loss number in the next quarter? So 2 out of these 9 students could not make any predictions, so we marked them as right answer. And 7 out of these 9 students, although they identified that it was not happening at a constant rate, came up with some number. Now, the 2 students who could not make any prediction, they said, they wrote justifications such as, I can't say because the progression of the number is not going at a constant rate. Another student said that the next quarter would certainly be more than the last quarter, but that's sort of the extent of which I can predict. However, we were very curious that how did they even know that the job loss in the next quarter will be even higher? Since we did not have the chance to talk to these students, we could not find anything more about it. Now, the 7 students who identified in the previous question that job loss was not happening at a constant rate, but came up with some number or some prediction about future joblessness, they came up with responses such as, one student, for example, they said, identify the number of job losses for June 2010, that means the last quarter, then multiply that number by 1.01, representing a 1% increase. And here is the thing, they made some assumption. So they made the assumption that the job loss in the previous quarter will remain the same. That means the job loss in the last quarter will be same as the job loss in the next quarter. And they kept that rate of job loss constant, and based on that assumption, they predicted that the job loss in the next quarter will be 15.5 15 million. Here I'm not going into the correctness of the mathematical calculation, but it was interesting that most of the students who could make any prediction for the third question actually made those predictions based on some assumptions. Conclusion, consistent with previous research, our study also shows that students are better able to read the data and read between the data and reading beyond the data. Second thing, we noticed that students are better able to read or interpret bar graphs than line graphs. And the third thing we noticed is that students who had some trouble interpreting the graphs, especially for the line graphs, they focused more on the shape of the graphs rather than on the number. One important and concerning thing that we noticed in this particular study is that none of the students could identify that any of the graphs are misleading. However, they were able to read the data. So combining these two, we were concerned that, okay, if students can identify any misleading graphs, but they could read the data given in the graph, does that mean that students will be easily, would easily believe any data that's given in the graph? So this is again, a first step towards the study. We are looking forward to reconduct the study and probably go for clinical interview with the students in order to know more about the different factors that actually impact their interpretation of graphs. Thank you so much for your time. Again, if you have any questions, please feel free to ask me and I'll be very happy to answer them. Thank you again.
Well, thank you, Debasmita.
Sorry, it was a bit rushed. And just to answer Luke's question, they were undergraduate students and most of them were in their freshman year. So yeah, between 18 and 20.
Great. So thank you for the presentation, and there will be time later on for discussion in small groups and later on some additional communication with the authors. So stay with us.
Thank you.
And I would like to move forward to Victor's presentation. So Victor Piercey is with us also from the United States. He is a faculty member at Ferry State University in Michigan, where he is a professor of mathematics and director of the honors program. His teaching and work focus on the intersection of quantitative reasoning, data science, and social justice. And he holds degrees in humanities and law and a PhD in mathematics, which I guess are all needed in order to understand human justice and social justice issues. So Victor, go ahead.
Thanks. So what I'm going to share with you is something that this isn't my project. I've participated in it, but I'm really speaking on behalf of a larger group. This is related to work in progress, but what I'm going to show you came out of a workshop on the intersection of education, data science, and social justice that was held at ISERM this past summer. It's the Institute for Computational and Experimental Research in Mathematics over at Brown University. So the leader of our group is Bianca Thompson. That's why her name is in bold. She couldn't be here today. She's at Westminster College, I think it's college, in Salt Lake City. She inherited this project of writing an open source quantitative reasoning textbook for focusing on social justice from her colleague Kenan Ince, who was also at Westminster, and sadly they passed away over the summer, and Bianca inherited this. So we got together to help flesh out this idea for a chapter studying anti-trans legislation. So this concept is kind of, if you look at what's been happening in the United States over the last several years, there's been this kind of increasing agitation against the LGBTQ community, particularly focusing, but not exclusively, on the trans community. And there seems to be more and more legislation coming out. So Kenan actually gathered these databases of legislation to track the legislation. And so we thought, well, what will the data show, and how could we use that to help teach students to do data storytelling through visualization, right? And answer their own questions through visualization. So what I'm going to do, this slideshow was something we prepared for ISA. I'm just going to pick a handful and show you some of the visualizations we made, and then some of the learning objectives we think you could use this data set could be used to teach. The first question we were wondering, was 2023 the year of anti-trans legislation? And when the data we had compiled went through, I think, May of 2023, and we did this work in early July. So what this graph shows is the total number of anti-trans bills introduced in state legislatures across the United States. So we can see that number seems to be going up. If we focus on the shape, as Debas Mita would tell us. However, we also examined both the absolute number of bills signed, but also the percentage of bills signed, right? So these were signed and enacted as opposed to just introduced. And so the number signed and enacted seems to be growing, but we notice the percent has shrunk. And when you think back to, what that denominator is rising, but not all of them are getting through, and not all of them are being signed into law. So if you're familiar with the current state of state politics in the United States, you might think, this makes me think of states like Arizona and Kentucky, where there are Democratic governors and Republican legislatures. Another question one can ask is, what is the subject matter of the legislation? What does the legislation address? So we've got all different types of content between youth athletics, drag performance, and so on and so forth. And you can see in the data kind of the story for each of these. So for example, between 2018 and 2023, focusing on trans participation in school athletics kind of seemed to reach a peak in 2021 and seems to be falling off, whereas healthcare laws seem to be growing, right? And anti-drag performance laws entered into the story in 2022 and seem to be growing in 2023 at the point at which we got this data. Right? Other things we can do with visualization is using textual analysis, right? So we can examine, do some like basic natural language processing. What we basically did is we did word frequency, right? We compared bills based on their word frequency. So we were able to get the legislation, we were able to pull the text, we were able to do a lot of cleaning. I was able to leverage my law background to help the team that was doing that. And then we visualized word frequencies. And there's a bunch of us there working at it in that picture. So you can see the words here. This is we can compare, for example, just the high frequency words in a law that was passed in Arkansas versus a corresponding law put out by the Heritage Foundation. So if you're not familiar, the Heritage Foundation is a conservative legal think tank in the United States, and they make model laws that they then send out to all 50 state legislatures. And since they're conservative, the Republicans introduce these things and try and get them passed. So you can start to see some of the differences in some of the words. There's quite a few. You can see the Arkansas bill had a lot of rewriting, and that comes in not just what gets introduced, but also in the negotiation and final passage of the bill. As opposed to, we can also compare the Arkansas bill to the bill that one that was in Arizona. And I mentioned Arizona has a Republican legislature and a Democratic governor who vetoed this bill. And you can see the words that are focused on, and you can actually look at the tone of the words. There, things like unemancipated students, minors. This focus on minors, which is the area where there's this focus right now on is kind of a way of getting at the trans community, persons, schools, employees, right? Restrictions on employees, what employees can do. Are they allowed to, for example, use preferred pronouns or not? Right. And so the other thing you can do is you can compare the anti-trans legislation word frequency to the words that are popping up in laws that are supportive. For example, Illinois passed the Given Name Protection Act in June 2023, and you see words like somewhere in here, care, right? Care is a fairly common word that's coming up. These more supportive terms, the sentiment, the connotation of the words can change between the two laws, which actually gives rise to some directions I'm going to be, me and a few other people, including some students, are going to pursue in terms of research and the role of stereotype in the anti-trans movement and how that relates to genocide. So that's just some of the stuff we did, and how does that show up in the classroom, right? How can these visualization tools be used in the classroom? And one of the ideas we have for this book is to have these interactive R code cells where you'll have some R code here, and then you'll have students go in and retype a couple of things to specify different like data sets or something like that, and then click evaluate R, and that'll generate the graph. So you don't have to know R. All you have to do is kind of know the data sets you're working with, and you can make sufficient changes just knowing what you're doing without knowing any R at all, and then just evaluate R. So with that, some of the things that we can do are use qualitative and quantitative stories to present data, to present these stories about people harmed by legislation targeting specific identities. You can take these analysis of these bills and find out how is it impacting real people and combine those to do some data storytelling. They can assess and articulate the limitation of what the data set alone can tell you, and how it can answer questions and how to formulate questions based on data. So you might look at some of these data sets and some of these visualizations, say, oh, I have this other question, and how do you dig into that? You can describe some processes for analyzing textual data. So we were, and do data storytelling with that visualization. So that's looking at things like the word count frequencies. That difference in this graph between the number of bills passed and enacted, signed and enacted versus the percentage gets at justifying the choice between absolute and relative frequencies when communicating with count data. You can also, and I think this is probably the biggest one, you can use these data to start generating calls to action to get folks to actively participate in their community and advocate for better lives for themselves and for their fellow community members. So that's my story. I think I came in under 10 minutes, so that was my goal. Thanks.
Thank you, Victor. Very interesting and very different. We move now to the last closing short talk by Charlotte Arkenback. Charlotte is from Sweden, a senior lecturer in pedagogy and a postdoctoral researcher at the Department of Education and Special Education at University of Gothenburg. She is also an ALM trustee on the board of ALM. She has worked as a teacher for over 20 years, teaching multiple subject areas, including, but not only mathematics at all levels, including adult education. And her research and pedagogical interests include digital communication, visual thinking, learners of mathematics and learning of mathematics, and related topics. Charlotte, go ahead.
Yeah, I also have recorded a video, so I'll share with you. Hi everyone, I'm Charlotte Arkenback, a senior lecturer at the University of Gothenburg and a postdoctoral researcher in applied IT focusing on workplace learning. Today, I'll discuss some reasons why people misinterpret visuals. As a secondary teacher of science, math, art, drama and Swedish, I always relied on visual representations to explore and explain scientific and social phenomena. With the advent of digitalization and digital technologies, I challenged myself to incorporate these new technologies for creating visual models. For example, I prefer sketching and drawing models when analyzing research data over organizing text in columns. However, in the academic context, my visual models often seem to lead to misinterpretations and critical discussions about their relevance. The significance of visuals is rapidly increasing in STEM education, vocational education, workplace learning, and in work. This has led to questions such as, is visual literacy an innate ability or can it be learned? Do some people excel at understanding visuals while others are better at text? Does being a text person make it harder to learn statistics and spatial geometry? Through my research, I've discovered that many teachers and presenters assume that visual aids like diagrams require no further explanation and use phrases such as you can see. Additionally, many participants and students remain quiet and don't ask for clarification on the visuals. I've also come across situations where the presenter is unable to explain a diagram when asked, claiming that they did not create the visual model themselves. This raises concerns about the skills needed to effectively combine visual representations and text. Visual literacy is crucial and it involves the skills of reading, drawing, constructing and interpreting visual models. It is a set of abilities that allows an individual to effectively locate, analyze, assess, use and produce images and visual media. Developing visual literacy skills is crucial for students to critically consume media in the digital knowledge society. Visual literacy is crucial in science and math, where interpreting scientific graphics require different skills than analyzing images in newspapers. It requires draw-to-learn skills, which are rarely taught outside of art. Visual literacy in retail work may involve bringing analog and digital visual data models into work routines, methods, customer interactions, and organizational goals. Cognition refers to the human brain's mental processes involved in learning, thinking, and information processing. Our knowledge about the development of numerical and mathematical cognition is heavily influenced by a theoretical framework that suggests humans are born with an innate sense of number, also known as number sense. This natural sense is thought to form the basis for developing numerical and mathematical abilities. There are two types of cognitive processes that play different roles in learning mathematics: executive functions and visuospatial functions. Visuospatial functions processing may explain the relationship between basic numerical skills and advanced math achievement, as suggested by Sella. For example, carrying and borrowing operations between columns require spatial working memory. Visuospatial functions or visuospatial abilities involve our ability to understand visual and spatial relationships between objects. These abilities help us navigate our environment by perceiving and processing information about shapes, distances, and object locations. They rely on several brain regions and are critical in helping us make sense of the world around us. Research has shown that people with strong visuospatial abilities tend to excel at problem solving, spatial reasoning, and visualizing complex concepts. Visuospatial thinking refers to the ability to visualize shapes and arrangements of objects in space, maintain a mental map of our location, and think with spatial representations of non-spatial entities. It varies among individuals and involves both analogical mental imagery and analytical processes. Orientation and navigation in large-scale spaces rely on visual and other sensory information. We often use spatial representations to think and reason about objects. For instance, we use diagrams, maps, and graphs to use vision to think. In preschool, children are introduced to simple maps that help them understand and interpret their world. These maps have a grid overlaying the image to facilitate the location and orientation of places and objects. However, research has shown that for some individuals, the physical structure of the grid becomes more prominent than the actual information it represents, which becomes the background. Graphical displays enhance visuospatial thinking by storing information externally, indexing information spatially, and allowing cognitive processes to be offloaded onto automatic perceptual and visual routines. However, a student's understanding of these displays can be impacted by factors such as their knowledge of statistics, correlation, achievement motivation, GPA, and visuospatial abilities. If having visuospatial difficulties, the same visual model may be perceived in this way. The Gestalt principles of perceptual organization explain how individuals naturally organize visual information into meaningful patterns and structures. This can be influenced by how the elements of displays are grouped and how well they are suited for their task at hand. Tversky argues that there are three natural connections between graphic forms and their meanings. For instance, lines represent connections, circles indicate cyclic processes, and the horizontal dimension is mapped to time. The art of representing three-dimensional objects on two-dimensional plane is called linear perspective. The simplest form of linear perspective is called the one-point perspective, also known as the central perspective. The concept of central perspective was first introduced by Brunelleschi, a renowned Florentine architect who lived from 1377 to 1446. The rules of central perspective can be summarized as follows. 1. The horizon line should always be a straight line. 2. Straight lines in space should appear straight in the image. 3. Sets of parallel lines converge at a vanishing point. 4. Lines that are parallel to the picture plane should appear parallel in the image. Nowadays, linear perspective employs 1, 2, or 3 vanishing points to achieve the desired outcome. The linear perspective is used in books, educational materials, as well as spatial geometry to depict three-dimensional objects. However, it is not an inherent or natural way of perceiving visual information. It's a learned and adopted way of representing space and depth in artistic or visual communication. In order to comprehend a 2D image that represents a 3D reality, it is crucial to understand the image conventions utilized by the creator. According to Panofsky and Franker, the central perspective is a cultural convention that must be learned through education or other means. During my time teaching adult education math classes, I came to understand the significance of visuospatial thinking. Some second language learners with limited educational background struggle with math and made little progress. When I asked them to describe the visual representations of a square and cube, I realized they did not perceive any difference between the two. After 10 weeks of training in perspective drawing, the students were able to distinguish between 2D and 3D objects with ease. However, neither the students nor my colleagues made the connection between these new skills and mathematics learning. Visuospatial difficulties can manifest in various ways among students, such as ignoring diagrams while reading textbooks, difficulty interpreting schedules, tables and charts, and taking a long time to retrieve information from visual models. Other signs include misplaced numbers and text in tables, schedules and graphs, and neglecting the use of grid lines while drawing objects, resulting in wrong or less precise answers. Teachers may provide feedback such as "be more precise next time" or "you've been careless here." But it is important to also consider the visual representation of the math content. Neglecting visuospatial representations in the feedback may contribute to the development of math difficulties. The main takeaways are as follows. Visuospatial abilities and thinking are not innate traits. They are personal, vary among individuals, and can be significantly improved through dedicated training and practice. By developing these skills, individuals can improve their spatial reasoning and problem-solving abilities. It's essential to incorporate visual literacy into classroom, so the students can develop their visuospatial abilities. Ensure that visuospatial displays are effective and accessible for all individuals. Avoid saying, as you can see, when referring to visuals. Ask students what they see to guide reasoning and problem solving. Thank you for listening.
Thank you, Charlotte, Debasmita, and Victor. That was excellent. Wonderful presentations here. What we'd like to do right now is for about 5 to 7 minutes, we'll break you up. And my main question, we'll just throw out the question of just chatting about some of the main themes among the presentations and anything that is applicable to yourself in your context, and what you would like to further learn about. So 5 to 7 minutes, just chat, and then we'll bring it back and do a bit of Q&A and share out. All right, so I'm gonna open up the rooms here. Does anyone want to share? Or I could see all of the microphones were going off really well in there. So perhaps there were a couple thoughts emerging that are worthwhile to share. Anyone have anything? What did you chat about? Questions for the presenters?
Well, I'm going to confess that in our group, we introduced ourselves and found some things of interest. We didn't quite get to the question, though.
I know, we really need a longer time frame, don't we? Yeah. Well, that's good. I mean, that is a very relevant and important piece of our work here as educators.
We found things in common, and I think that's really useful.
Yeah. Great. Well, Diane, did you want to say anything about things that are coming up with ALM, perhaps, just to close us off, and we can just, whoever wants to hang out after can do so.
Yeah, I mean, meanwhile, if people are thinking, please feel free to pop things in the chat, because sometimes it takes a while to think, doesn't it? So if I just give 1 or 2 notices about ALM, I'll give you more chance to pop something in the chat and think about something, because you can just switch off whilst I'm talking, can't you? But anyway, so things coming up. We are planning another seminar in January. I'm not sure whether to say who's doing it, because that might put people off, Judy, but I'm leading the next seminar, and it will have something to do with my recent research, and it may involve some other people, but the details will appear on the website soon. I'm going to make another promise too. We have a conference next July, and we're working on that one at the moment, and we're working on an interesting hybrid type conference where we will have probably 2, maybe 3 face-to-face clusters, but everyone will be able to access online as well. So some clusters might be totally online, some clusters will be hybrids of people face-to-face in room and those joining online that can't, in different time zones. So right around the world, there should be sessions that you can access, and everyone will be following the same keynote presentations with some regional variations in terms of other presentations. So it's an exciting new development that we are working on to make it accessible to everyone, and to cut out some of the expenses that happen when we just have one face-to-face venue. Trying it out. So that's my exciting notices. Have I forgotten anything, Judy?
I mean, I think that's excellent, and we are thinking about the following year conference potentially being in Canada, but that is still in process. And yeah, so we have our next seminar. We will email that out to the list, and we also have a feedback form that Linda is going to. I'm going to just send out to everyone here in the meeting. So if you have some feedback on the seminar, please feel free to contribute your thoughts. And we also just want to thank the three presenters today. Those were very excellent presentations. I learned a lot, and I definitely would like to follow up with some of the ideas. I particularly like the social justice spin that we were able to bring in. So thank you for those shares. Excellent. Well, thank you all for coming, and we'll hopefully see you next round.
Yeah, I think the date to fixing your diaries is January the 15th, provisionally. And
yes, January 15th.
You will be able to access this recording online on our YouTube channel.
Thanks, Diane.
Thanks, everyone.